Good morning, everybody. It's my pleasure to answer a lot of questions from these presentations we've had earlier this year on radar. And I'm no expert, but I knew someone who was. And having followed up at the Trevecca meeting in February, he was kind enough to volunteer to come talk to us as weather spotters. So with all these questions on weather radar, it's a complex tool. And everybody can get it on their phone and everything, but do you know what you're looking at? Really. And as weather spotters, we need to be able to understand how to interpret it a little bit better for the role we play in the emergency service side. Our featured speaker has been forecasting weather in Middle Tennessee for over 42 years on Channel 2, WKRN TV. And that's since November of 1981. He's an expert. He's one of the few broadcast meteorologists in the nation to earn the Certified Consulting Meteorologist from the American Meteorological Society, which is a very, very rare ranking in this business. And in his spare time, if you haven't watched him on TV, he loves fishing and music and sailing. He has a professional passion for radar. I saw him give a presentation 5 years ago, and I was just blown away by his technical expertise. And he joins us today to give us insight on the weather spotting community on how to interpret much of the radar we use as spotters. So please join me in welcoming Davis Nolan via Zoom this morning. Good morning, Davis.
Good morning, and thank you so much. It's a real honor to be able to speak to you guys, and I hope I can fulfill, the knowledge that you need. One of the things about the radar, there are a lot of products in there, and they do require some interpretation sometimes. But when you're out in the field, you guys as spotters, there's a couple of just main things that you want to be looking for, and some of them I'm sure you already know. And I know that most of y'all are looking probably at RadarScope. I was told that many of you have GR2 or GR3 analysts. In my, as Paul was just mentioning, I have the Certified Consulting Meteorologist designation, and that ends up being I get hired by these, like, attorneys will call me and they'll be building damage, and they need to know what the winds were, what kind of storm they had, was it a tornado, was it straight line winds, whatever they want to know, and then I have to go back and find the archived radar data and look at it. And I use GR2 analyst a lot for that, and I do have GR3. I don't use it as much. They're very, very similar. Now, imagine most of you, when you're out in the field, you're probably on your phone at that point, which means you're probably not on GR2 or GR3 if you're out in the field, in your car or something like that as a spotter. And you're probably on your phone more than anything else, which would mean you're probably using RadarScope. And I was at an AMS convention several years, it's been quite a few years back, but RadarScope had been out for maybe 3 years at that point. And I remember they asked, and it was about, all meteorologists in the room, and I think it was the broadcast convention, and the guy who was the president of the company that does RadarScope was speaking, and they asked before he got up there, how many of y'all have RadarScope on your phone? And I'm telling you, I don't think there was one person in the room that didn't raise their hand. Okay, and so I love RadarScope when I'm out in the field. And I don't have the luxury of a laptop and things like that. And I'm not always out in the field. Half the time I'm back in the studio. I wish I was out in the field, but I'm utilizing my phone quite a bit. And RadarScope's a great tool. When I'm analyzing after the fact, I'm almost always on GR2 analyst, because it gives me the most detail I can have. Now, I do bring, when I go out on our weather van, our storm tracker van, I'll bring my laptop and I'll have RadarScope and GR2 analysts. I'll have the advantage of both of them while I'm out there, so I can use them to position myself if I can try to get a view of a storm. But anyway, I'm trying to figure out which one to use. I wish I could pull up, because basically on our phone, RadarScope, and I just want to talk about some of the products. And I really want to say that the ones that you're really most concerned with are obviously the base reflectivity, okay, which you're familiar with, and RadarScope. I'll hold this up if I can, whoops, and it says reflectivity, and that's the one that you're most concerned with, and then velocity. Now, the one right below velocity is storm relative velocity, and I want to tell you what that means, okay, because it really does come in handy. All right, and I'm going to have to sort of just describe this with my hands. here shortly. But if you don't know what storm relative velocity is, and I find out there's a lot of people who are been using radar scope and are very knowledgeable about radar, at least as a non-professional, and they didn't know this. I know one guy who's a storm chaser who really knows his stuff, and I was explaining that to him one time at Trevecca, and he goes, "Wow, I didn't realize that's what storm relative velocity was." Well, basically, as you know, when you look at these reds and greens in the velocity mode, the red means wind going away from the radar, green means wind going towards the radar. Luckily, with a tornado, since it's going in a circle, you've got one side of the circulation going towards you, one side of the circulation going away from you. So you get that couplet of red next to green that you hear referred to as gate-to-gate winds and that type of thing. All right, well, picture this. A lot of times, and that's another thing I'm going to get into, is whatever you're looking at on radar, you're not looking at the surface. You're looking up aloft. And sometimes you're looking up 5,000 feet in the air. So what you're seeing isn't what's really happening on the ground. You see, 60 knot winds, and then if you check it out, you might find out, well, 60 knot winds at 5,000 feet, but that's not necessarily what you got at the surface. It might be, but it might not be. But back to storm relative velocity. Okay, suppose a lot of times you're looking at what we call the meso or the circle. We almost always look at the circulation aloft. You're not actually looking at the tornado right all the way at the surface. Now, when it gets real close to the radar, you're getting down where the radar beam's like 1,000 feet or below, you're probably seeing the surface. Still, you might not be, but you're probably a lot better chance that's on the ground. The lower it is, obviously. But it's almost always, you're always looking at something aloft. So you're looking at the meso. Now, back to storm relative velocity. A lot of times, like you could have a tornado on the ground with 100 mile per hour winds, but what you're seeing aloft is maybe 35 knot winds, okay? And let's say you have 35 knot winds, or let's just make it an even number, 30 knot winds. Okay, of red and 30 knot winds of green right next to one another, right? But what if the storm is heading straight towards the radar or close to straight from the radar? Okay, remember, it's not giving you the exact winds towards and away from the radar. It's giving you the component of the wind towards and away from the radar when you're in the velocity mode, okay? The regular super res velocity mode. It gives you the component. So if the storm's coming at a 45-degree angle to the radar beam, okay, you're not seeing the exact wind. You're seeing the component of the wind towards the radar. But either way, supposing it's coming straight towards the radar, and if the storm actually had 35 inbound, 30 inbound, 30 outbound. If you're in the regular velocity mode, it's likely to show you 60 and 0. And you will never see red and green right next to one another. Because the storm, I forgot to say, I apologize. And the storm is also moving 30 miles an hour towards you, okay? And it's showing 30 miles per hour towards and 30 miles an hour. It has 30 towards and 30 away. But what will be displayed, because the storm is moving 30 miles an hour towards you, that's going to make one side show 60 towards you, and the one that was away from you goes to 0 because the storm is moving 30 miles an hour and negates that red. So all you see is the green. Same thing if it's moving away from you. All you see is the red, but you never see the green. So the couplet helps us visually see where the rotation is. So storm relative velocity is exactly what it says. It's the velocity relative to the storm's movement, i.e. it subtracts out the 30-mile, let's say the 30-mile movement towards the radar, away from the radar. It subtracts that out. So it shows you the towards and away, red and green, next to one another, just as if you were riding in the storm itself or, not looking. So it subtracts out that movement. So if a storm is moving straight towards the radar or straight away from the radar and you want to see that couplet, a lot of times you might have to switch to storm relative velocity to see it. I've looked at some cases where if it's strong enough, you still get to see it, see the couplet. But if it's not, you don't. So storm relative velocity, that's an important thing to know, because I've used it quite a bit. When I see something coming straight towards the radar, I'll be in tracking with Danielle and I'll say, hey, we need to go to storm relative velocity if we want to make sure we see the couplet. Now, you don't have to see the couplet. I mean, if you don't want to, but you sure would like to. It visually helps you know what's going on. We're following the Weather Service's lead, so we sort of know where it is. But visually, we want to show the viewer. And if it's not showing the red and green couplet where we can draw a little circle around it, then storm relative velocity is really important. So, and the other thing is I mentioned, you need to know how far away things are. And what's funny is I've had radar scope for as long as it's been out, and it's something I didn't know. Okay, now I forget what version it is, but I'm paying $99 a year to get all kinds of extra stuff. And I mean, it gives me archive data for 30 days. I can go back and look at something for 30 days. And it maybe give me some stuff that the basic one doesn't have, because I haven't had the basic one in so long. But I think the basic one, if you look at those tools at the top, where you can draw with that one right there, and there's the one that you can query and look at like how many knots it is, and one of them is a distance tool. Okay, and let's see, I think it's the middle one. The middle one is a distance tool. Okay, when you click on the distance tool, I want you to watch this. Well, I'm gonna have to do this. If you look closely, do you see where the Nashville radar is? That little blue dot? Okay. I didn't know, but when you click on the distance tool, what radar you're on, that little blue dot appears. Okay. So I'm gonna try to do this. Put your finger on that blue dot and drag away. Well, I missed the blue dot. Sorry. Got it that time. Drag away. For example, you see the corner of that circle? It's saying that it's 4.1 thousand feet. So that number is telling you how many miles away the edge of that shower is over there, right? Over towards, looks like, I'm looking at this backwards for me, but it looks like I'm moving towards Humphreys County or so. Either way, it doesn't matter. The number that you see down here is how high the radar beam is. So I never knew that. Okay, Marcus Bagwell. One day he said, I said, "Bill, I sure wish we had a radar scope to see how high the radar beam is, because on a DR2 analyst, you just put your cursor there. There's a little box at the bottom that does that. But on radar scope, when you click on the distance tool, which is, at least on my version, is the one right next to the writing tool, you get the distance, but you got to click on that blue dot. So you can click from anywhere on the screen and get a distance, like from where you are, for example. But it's not going to tell you the height of the radar beam because you're not at the radar. But once you're in that distance tool, that blue dot appears. You put your finger right on that blue dot. It tells you the distance and the height of the radar beam. And that'll say, okay, that's how high in the sky I'm looking. This thing's telling me I'm looking. For example, if I was looking at something in Murfreesboro from the radar beam, from the National Weather Service OH radar, it's saying 1.7, I believe, 1.7 thousand feet. So 1,700 feet in the air is what I'm seeing when I look at it from Murfreesboro. I thought it'd be higher than that, but that's what it is. Okay. So that's a nice thing to know, and to know how high you're looking. Now, quite honest with you, with what you guys do, if you're going out in the field and you're trying to spot and you're trying to see stuff, now if you're in your house, that's one thing, but if you're in a car and you're out trying to see stuff, I don't know if it matters how high it is. You want to see those gate-to-gate winds, and then you want to observe as a spotter, do I see anything reaching the ground? Okay, do I see a wall cloud? Yes, I see a wall cloud, but do I see any debris circulating? No, I don't. So you want to report back, okay, we got a wall cloud, but at this time I'm not seeing any circulation coming out of the wall cloud at the ground. So just locating that wall cloud or locating that meso is important. So how high it is may not really matter if you're out in the field, but it's good to know that you're not looking at the surface, okay? And when NWS Chat first came out, we had a lot of people that would go on these apps and they would click on it and it would say 65 knots, and they'd go on, well, we're seeing 65 knots out here in Waverly, and come to find out they weren't observing that with their eyes. They were on this, looking at something thousands of feet up in the air. We got Waverly to be 5,000, 6,000, Lord knows how high up in the air. So anyway, it's important to know, but not going to be, since you guys are out trying to spot, the main thing is seeing where the gate-to-gate winds are, making sure you're in a safe place. It's always good to approach from the south if you got stuff that's going east-west or west-east, shall I say. Okay, now I'll turn that off and get rid of that. These other, basically, to me, the most important things for you that you want to use are reflectivity that you see there, the top one, velocity. Now, by the way, if the storm's not heading straight towards the radar or straight away from the radar, velocity is fine, okay? But storm relative velocity comes in handy if it's heading straight towards the straightaway. Now, there's storm relative velocity right there. Now, as far as the dual pole products, and we'll get into that here in a moment, little bit about that. The only one that's really important to you is correlation coefficient. Okay, that's the one that can detect debris. Okay, now we're not looking at a real situation right now. Okay, we'll look at one on TR2 analyst here in a minute. But correlation coefficient, okay, it just changed the world. Okay, for us, because as you know, the radar is just like we just explained. You're never looking at the surface. You're always looking aloft. And when the NexRad first came back out in the mid 90s, every time the Weather Service had gate-to-gate winds, bang, put out a tornado warning. You know, if it was low, you know, getting down below, let's say 3,000 feet, they, you know, and at night you had no other means of knowing what's going on. You know, once the correlation, the dual pole radar came out, you were able to detect debris, and suddenly there was a tool that you could use to know whether a tornado's on the ground or not, which is really important, obviously. And I think it's helped them reduce their false alarm rates, you know, by sometimes saying, well, we're not getting any spotter reports. We're not getting this, we're not getting that, and we're not getting a tornado debris signature, which is what correlation coefficient does. Okay. And I was going to go to one of these presentations. Give me a second. I'm going to go down to where we talk about the dual pole, and I'll share my screen. Hopefully it'll work. So anyway, when dual pole came along, okay, originally the radar only put out a horizontal pulse, okay? And all it did was measure the horizontal characteristics. Like when you were looking at reflectivity, it was measuring, it was polarized for anybody that's sort of into engineering horizontally, the radar beam, okay? So all it showed was the horizontal characteristics. Now, by the way, people think of raindrops as being tear-shaped. They're not tear-shaped. Most raindrops are like, you see the little raindrop in the bottom, it's oblate and it's wider than it is tall instead of taller than it is wide, because it's the friction of the air as it's dropping, falling through the air, the friction squishes the drop. So most raindrops are wider than they are tall. A lot of people don't know that. Anyway, when dual pole came along, it sends out a vertical and a horizontal pulse. So it's measuring the characteristics both vertically and horizontally. And what's important about that is that most raindrops, as we mentioned, are all wider than they are tall. So they all look the same. Okay. So when you see rain, it'll all look the same. They'll all correlate, all the targets that the radar is bouncing off of look the same. But if you have debris, some things are taller than they are wide. Some things are wider than they are all tall. So the radar, it's sort of a post-analyzation. The computer does it for it. After the radar gets these pulses back, where it's bounced off one thing that's wider than it is tall, another thing right next to it that's taller than it is wide, another thing that's both, another thing, and they're all mixed up, jumble. Well, they don't correlate very well. So they have a low correlation coefficient. So a low correlation coefficient means all the targets don't correlate very well. A high correlation coefficient means they all correlate, which means they're probably all raindrops because they're all the same, okay? So that meant they could use this correlation coefficient to detect debris. And for example, on the top, you see base reflectivity, top left, and this one's got a nice debris ball in it, but the reflectivity has that big red thing, so it's obviously almost picking up debris on its own. And then, by the way, there's storm relative velocity. It happens to be using on the top right. So this must have been heading towards the radar, so they wanted to use storm relative. The bottom right is correlation coefficient. And you see all those little numbers like on the top left, it goes from 0.2 to 0.65 to 0.8, 0.99. Notice the reds are all like 0.97, 0.99. That means they all correlate well. They're 97 to 99% correlating just fine with each other, okay? You get down in those blues and yellows, you're suddenly getting from 80 to 70 to 60% to maybe even only 20 to 30% correlation between the targets. So they're not correlating very well. So they're all different. So they're likely to be debris and not raindrops. So that's really important. But I'm going to have there's a lot of forewarning about it. By the way, on the bottom left, I didn't label it. That one is differential reflectivity. You might use that one, but I've just found that it doesn't really, for me even, help me much. Which all differential, and I won't last long on it. Differential reflectivity takes the reflectivity horizontally and subtracts the reflectivity vertically from it. Okay. So since a raindrop's usually wider than it is, it'll have a high horizontal. Okay. And debris could be either one, right? Or higher vertical. But if you subtract the vertical from the horizontal and it comes out a negative number, then that means you've had a lot of things that were taller than they were wide, which means they weren't raindrops. Okay. So that would make your differential reflectivity negative. So theoretically, this would be sort of like using correlation coefficient, but it's only trying to find things that are taller than they are wide. And that little shade of gray you see in that bottom left panel of the circle is like a negative or very low differential reflectivity. Personally, I don't hardly ever look at it, okay, because correlation coefficient does better for me. You can see, can't you tell, a lot better. And both of them, look at all the noise around them. I mean, I want you to look at this picture, okay? You see all those areas where I have the writing correlation coefficient. You see lots of greenish and bluish stuff up there, right? None of that's debris, okay? Look way down there where we have a little oval-shaped circle. That's the debris. And that has to line up. And we don't have the gate-to-gate winds here. But I remember before this even came out, Tom Johnstone, who many of you may have known, was the previous warning coordinating meteorologist at the National Weather Service. And he warned us, he said, look, when this dual pole comes out and you see correlation coefficient, you're going to see stuff that is low correlation coefficient all over the radar scope. The only one that counts is the one that lines right up with the gate-to-gate winds, that red and green. So like on radar scope, a lot of times, I know a lot of y'all, and I'll hold my phone up again here in a second, but on radar scope, I know a lot of y'all can do the split screen. I don't know if that comes with my, by the way, here's another example. This was a Lincoln County tornado. I'll go back. That was it on radar, and it even had a good debris ball. This is back 2000, gosh, I forget what year it was, but it expanded like that, and that was actually all debris there because that's how it expanded after time. But anyway, let me get out of this and get back to what we're going to get escape. Where's escape on my computer? Maybe the curse. Yeah, that'll let me get out of here. Wait a minute. I don't want to get out of. I'm trying to make sure I don't dump out of. I'm only dumping out of. Let's make sure. I don't want to dump out of you guys here. Okay, you hit the wrong X, and next thing you know, you dumped out of Zoom. Sharing is stopped and sharing windows closed. Okay, back to radar scope. A lot of y'all probably. I hope that everybody gets this and not just me because I'm paying more money. I normally, for example, I can hit this. If you have this icon at the bottom of your screen, it means you can look at two screens, and you click that. And I usually have reflectivity at the top and super res reflectivity at the bottom. And I'll sometimes switch that super res to the bottom one to store relative velocity. Okay, so I can see two of them at one time. Okay, and if I finally have a good gate-to-gate winds right here, a lot of times I'll go back up to this one and I'll change it to correlation coefficient, and I'll see. We don't have an example here for me to show you. But if, let's say I got some gate-to-gate winds like right here, I want to look right where the gate-to-gate winds are and see if I got that low correlation coefficient right there. And just be forewarned, like that slideshow showed you a minute ago, you're liable to see low correlation coefficient all over the screen. It doesn't mean there's debris way over here, debris way over there. No, it's got to line right up. You want to see the red and the green in the exact same spot as you see that correlation coefficient, okay? Now and I wish I could call this up for you, but I don't have the URL saved. When they were training, they had a training course, and maybe you can Google it. It was a training course on dual pole radar. And they warned you, a lot of times we'll be looking at correlation coefficient, we'll see this big long line going through it. And it seems to be very common. And sometimes hail contamination, they called it non-uniform beam folding or something. And it'll just make this big long line right through it. And it ruins everything because there may be some debris in there and you can't see because of that. And I know Danielle and I have been on Storm Tracker many a time, and we'll click on correlation coefficient and she'll say, Davis, what is this again? I say, yeah, this is that non-uniform beam folding. Unfortunately, it interferes with us being able to look for debris, but if we find something, especially when we animate it, if you find something that's moving with the red and the green and it's moving right with it, And that's where that split screen, if I hit animate and I see the red green coupling go tick, 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 and I see that correlation coefficient low go tick, 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 and it's following right with it, well, then that tells you that you've got debris, and that means it is on the ground, or at least it has been. It could have lifted and the debris could still be flying around. But that's so important. And I just think that the main things that you really want to know, you look at are obviously reflectivity, your velocity and storm relative velocity, and then correlation coefficient. All the other Dual Pro products, I mean, you've got, oh God, some of them really do help you in snow situations, but I really don't. I think you guys are more concerned. And when I say help you with snow situations, I don't think they help you as a spotter with snow situations. There's things like looking at the melting layer up at 5,000 feet and stuff like that, you know. And I don't think, you know, you as a spotter, they want you to, hey, is it raining or is it snowing at your house in Franklin? You know, so obviously if you're looking at this KDP and you're looking at the melting layer at 5,000 feet, it's probably raining at your house if you're within that, you know. So super res reflectivity or reflectivity, velocity and storm relative velocity, and then correlation coefficient. Those four things are what you want to look at the most, okay? Now, I should go on share screen again here. Give me a second. And I usually use GR2 Analyst. I have GR3 also, GR level 3 or whatever it's called. But 99% of the time I'm on GR2. The reason I got GR3 was because the terminal Doppler radar, many of y'all are familiar with, matter of fact, I can show you real quick on RadarScope. I go back to my single screen and just put it on reflectivity. The terminal Doppler radar in Nolensville, okay? I've turned off the cities for right now, but you see, TBNA, as you guys know, you can drive down the road in that area. I just switched to the terminal Doppler radar. And so I found out one time I was doing a court case for some building damage, and it was in Memphis. And Memphis has a terminal Doppler radar. And I wanted to see both of them. Well, I came to find out that I could not, apparently terminal Doppler radars use level 3 and GR2 Analyst uses level 2. And I won't get into what the differences those two are. I don't personally know the details of what the differences is, but level 2 is supposed to be a little bit finer resolution than level 3. When we first started the NexRad back in the 90s, it was all level 3. And then level 2 came out within, I don't know, 5, 6, 7 years. And it was supposed to be a finer resolution, okay? And so I'm most time on GR2 Analyst, but they both more or less do the same thing, but they have some slightly different twist to it. And I know some of y'all, I'm going to hit share screen again and see if I can do this correctly, which, let me see, where's my GR2? All right, that's it right there. I've loaded, I think y'all can see this, what I've loaded up here is the December 9th tornado that went through, it went through the northern part of Nashville, Madison. The worst damage was like the Madison area. And then it went through Hendersonville, as you probably know, did a lot of damage there, and then continued to do damage over in into Macon County, past Gallatin over into Macon County. But I'm showing you that right now. And what you're seeing, of course, are the warnings that are being displayed. Of course, on the left, I've got base reflectivity. And on the right, I've actually got regular velocity. And even though this was heading, I pulled this one up because I was hoping that it would be hard to see the gate-to-gate winds because it was coming so straight to the radar. But it was on just enough angle where on regular old base velocity, it was still showing it. Let me see if I can move my screen over. Here we go. Let me move this over here. And just for the fun of it, I'm going to switch it to storm relative velocity and see what the change is. If it looks any better, I'll stop it as it gets closer. So, no, I mean, really regular base velocity worked just fine. The colors are a little brighter, but this is storm relative velocity you're seeing on the right now. Okay. And like I said, if that gate to gate wind had not shown up, okay, then, if that had not shown up, then we would have gone to storm relative velocity, but it did show up. I'll go ahead and put it back to regular base velocity, which is up here if you can see my cursor on the top right. And again, this is GR2 Analyst. I'm able to do this split screen I have GR3. I don't know if it lets you do a split screen or not. Unfortunately, I'll be quite honest with you, and I apologize to those of you who have GR3, and I'm looking at Atlantis radar because it just defaults to that. It's got precip on it. I'll have to look around to see if it lets me do a split screen and I know it's going to let me do change my like supposing I want to look at base velocity. There's the base velocity. I can look at storm relative velocity at different. And by the way, 0.5, 0.9 means obviously half degree angle, 9/10 of a degree angle, 1.5 degree angle. So you can look at all the different things. It does have windows. Okay. Show placelift. No, show, panels. Okay. So we can do 2 panels here. Okay, good. So I can put, in this panel, I can put base reflectivity at 0.5, and I'll click on this. I clicked on the right side, and I'll change it to base velocity, 0.5. So there we are. GR level 3, if you have that, does have a split screen option where you can look at 2 of them at one time. I often actually like to look at 4 of them at one time, and I'll stay on level 3. And we're doing the same thing as level 2, except that things are in just slightly different places. Panels, was it 4 panels? And I'll put down here, I'll put storm relative velocity, and down here, I'll put correlation coefficient, CC. So now you're looking at, base reflectivity. I'll put this full screen again. You're looking at base reflectivity in the top. You're looking at base velocity, top right, looking at storm relative velocity, bottom left, and correlation coefficient, bottom right. And I'm going back to my thing on GR2 Analyst, and I can do the same thing here. I'm trying to move things around where I can, if it'll let me move it so I can see it.
We could not see the GR level 3 example you just gave. It stayed on 2 as you were presenting.
Oh, it did. All right, let's see. I think let's go back to it then. I apologize. I'm glad you told me. I know why, because I didn't use that folder, I bet you. I got to go back to screen share. Okay, let's go back here and do it again. Now you got it, right? You see,
here it comes. Yes, now we see GR level 3. Thank you.
I apologize. I didn't realize. I forgot. I have to go into this one spot to grab things, or it doesn't share. I need to move things around so I can actually move this. Apologize if it didn't go full screen, but anyway, it does have a panels here where I can do 1 panel. Okay, and that's what most of you probably do. And of course, in that 1 panel, and I know I don't have this totally full screen, but for me to be able to see these, I can change that to base velocity. I can change that to storm relative velocity. I can change it to correlation coefficient right here. But like I said, over here under panels, you can go 2 panels. And so and you click on that panel, you choose what you want. You click on the right panel, and I'll choose storm relative velocity this time. So I can do 2 panels there. And like I said, a lot of times what I'll do is I'll make 4 panels, and I'll make the top right my base velocity, and my bottom left storm relative velocity, and my bottom right correlation coefficient, which I guess I already have. So I have all 4 of them at one time. Okay. Now we don't have any severe weather in Atlanta right now, but you're actually, if you did, and by the way, look, see how it's showing all this, what looks like low correlation coefficient. There's no tornado. There's no debris. That's why the correlation coefficient has a lot of noise. Okay. But it only when you have gate to gate winds that or a tornado, they're lining up with a hook or whatever, inflow notches on base reflectivity. The Weather Service has told you there's tornado warning for this storm 5 miles southwest of Franklin, and you look right just southwest of Franklin, you find the gate-to-gate winds. Then if you see the correlation coefficient where those gate-to-gate winds are, that probably means debris. But here we are in a non-tornadic situation. That bottom right panel is showing you all kinds of, it looks like debris. Oh, no, there's debris. There's not even a tornado. There's not even a thunderstorm over there right now, probably. Well, maybe there is, but, so that's important. But anyway, so this is the GR level 3 that I don't use as much, but it has a lot of the same things as level 2. I got to go back to level 2. And let me ask this: can you see level 2 now, Paul?
No, we're still seeing level 3 at this time.
Okay, yeah. So I got to go back to that. What I have to do is got to hit screen sharing and see if it'll give me that. Well, It's got to give me that folder. I don't know why it's not. I'm going to hit stop share and start over again. So when I go to screen share, I'll pick level 2. We'll just do it that way. Here it is. Okay, I'm back to level 2. And I don't know how many of y'all have level 2, but I can do 4 screens with this one. Okay, you should be able to see it now. I can do 4 with this one as well. I want to pull this down just if I can grab it and pull it. Come on. I'm trying not to X out of right now some of my like the screen share chat, turn your mic on and off, that's at the top of my screen. And because that's at the top of my screen, it's covering up some of the things that I want to show you. And I'm just trying to drag this down. There's probably a way for me, but either way, I can do 4 panels on this also, okay? But a lot of y'all, I know, Paul, you'd mentioned some people wanted to know about these icons. For example, this is that tornado that went through Madison and Hendersonville on December 9th, okay? And let me zoom down further still. And of course, there's the tornado warning, and we'll go back a little ways. It had been on the ground, and I forget exactly where, you're seeing a tornado signature the whole time here. Gosh, I really need to, let me see, how can I move this? Hide, share sound, meeting info. I'm just trying to, I can't click on anything because of my toolbar is covering up the things I need to click on. And I'm just trying to see if there's a way I can grab this, or if it'll let me move yeah, it does. It let me move that. Thank God. Okay. Y'all, if you're seeing my screen, I just moved the toolbar. But now I can see what's up here. Okay, that's all I want to do. I can do panels on this one and do 4 panels also. And I can make this one, like I said, I'll make this one. I click on that left panel and I want to make that storm relative velocity. That's over in the top right now. That you could do it up here too, I guess. I could pick it here. And then I click here and I could pick it up top left, or I could pick it over here. I'm going to make this last one correlation coefficient. And it does look like at that point, and I'm going to point something else out. We see some gate-to-gate winds here. We are seeing, and I'm assuming you see my cursor going around a circle. The bottom right is correlation coefficient, okay? And I'm circling a little area that does look like it's showing debris, okay? And our gate-to-gate winds are close. And I know a lot of y'all want to know what these were. These, what they're calling their MDA icons, okay? Now, what they are is they're trying to show what they call normalized rotation, okay? And this is really, it comes in handy. It's not perfect, okay? And as you notice, it's not lining up right where the gate-to-gate winds are. And the radar does, and my experts at the Weather Service knows them, these radar scans are all coming at slightly different times, okay? So that little threshold that it's showing may have come from a scan that was like 60 seconds earlier than the one that's showing you the red and the green, okay? So that's why it's not right on where the red and the green are, okay? But it's nearby, so it's important. And I went ahead, and let me see if I can do this screen sharing. It'll give me that folder again. Oh, well, I may have to temporarily stop share, go back to screen share, and I'll try to grab this folder where it showed you. Yeah, save this. All right. First of all, well, let me go to, are y'all seeing that right now?
Yes, seeing definition.
Okay. Yeah, and I really need to show you something else first before let me stop that. We're going to come back to that in a second. Screen share, and I want to grab, I believe it's this one. There we go. And I need to move my little thing again. I hope I don't want to stop video or anything. I'm going to grab this guy. Yeah, there we go. All right. And now that is, I got things covering up things here. How can I move things around? Well, will this move? I think it will. Yes. All right. Sorry. Now, Are y'all seeing all the little icons on the left part of your screen?
Yes.
Okay. And if you can read, I don't know if I can make my screen larger. What it says GR-MDA icons. And the I'll read it for you. The GR-MDA icon sheet here has 2 rows of 4 icons. The top row is shown when the mesocyclone, or that rotation, which you're seeing aloft, that base is above 5,000 feet. It puts those little circles. Okay. So apparently from below 5,000 feet, it puts those upside down triangles. We're trying to imitate maybe a tornado, let's say, upside down triangle icon trying to indicate more of a tornado type thing. Not necessarily that it is, but excuse me. And that would be when it's below 5,000 feet. So above it's a circle, below it's a little upside down triangle. It said from left to right, the icons indicate 1.0, 1.5, 2.0, and 2.5 average INROT strength for a mesocyclone, which corresponds to weak, moderate, strong, and extreme levels of rotation. Okay, so now I'll get to what INROT is, and it stands for normalized rotation. But basically, it runs from 1 to 5, or maybe I think it's negative numbers to 5. Okay, anything above 1.5 is important, and the higher it is, the more chance that you have the stronger the rotation is, the better chance it might be on the ground. There's hail icons also. On the bottom, it says hail, like the hail icon sheet has 5 rows of 4 icons. Each row corresponds to the inches in the estimated hail size. Each column represents 0.25 increments. Okay. So that's what those icons are. Now, what INROT is, I'm going to stop sharing temporarily and grab that definition again. There's probably a way to do this without stop sharing, but as long as this is working, I'm going to keep going. All right. Are y'all seeing? I got to move this again if I can. I'll move me first.
Yes.
Then I'll move this guy here second. Okay, there we go. INROT stands for normalized rotation. This is a fairly complex derived product that tries to find areas of rotation in d-alias BV, base velocity. It does the following, and reading this is like reading a bunch of Greek, okay? The last paragraph, the result is INROT, okay? With a range of -5 to +5. Anything above 1.0 is significant, and values above 2.5 are extreme, okay? So all you need to know is this is a derived product using a bunch of computer stuff and a bunch of the velocity products, and it's deriving this product that tries to define rotation on a base of -5 to +5, okay? So, and it's saying anything of 1.0 is significant and values of 2.5 are extreme, okay? And then I'll go back to our little icon sheet, and I'll probably have to move everybody out of the way again. Well, don't. Are you seeing the icon sheet now? Are we back? Yeah, let's go back to it. And then, of course, this is what they all mean. Now, I can't look at them both at one time, but we're going to go back to GR2 analyst, if you don't mind. But basically, you can see when that red one there, that's going to become important. You see a green one, the very first one we were seeing when it was back just outside of Davidson County was a green one. And so that meant it was below 5,000 feet, and that would have been 1.0. Okay. So, and then the yellow would be 1.5, the red would be 2.0, and then the purple was 2.5. And they said it goes all the way up to 5, but I guess once you get to 2.5, they said that's extreme. So let's stop share, go back to GR2 analyst, share screen, see if it'll give me my folder again. Come on, baby. Make sure I grab the right one. There we go. Okay, so there we are, and I'm going to hover my cursor over it, and it's saying the threshold is 18.7. Exactly what that means, I don't know, but below, notice it says 1.2 at 8,062 feet, 1.3 at 6,386 feet, and 1.1 at 3,746. Now, 2 of those 3 are above 5,000 feet, but I guess it's showing you a upside down triangle because the bottom one is below 5,000 feet. So I guess if it has one of them that's below 5,000 feet, it makes it a triangle, okay, instead of a circle. But the bottom one is saying it has a 1.1 at 3,746 feet, okay? So now that doesn't tell us there's a tornado on the ground or not on the ground. It just tells us that's what it's seeing, okay? Again, it's a derived product. You don't want to take any of these things as exactly God's word. You want to take them as another piece of data that you can use to try to analyze things. Okay. Now, for me, if I'm on TV and I go to that bottom right screen and I see that debris in a circle there, and it lines up close to where these gate-to-gate winds are. Notice we have a big area of red there, but there's a smaller one here. I'm going to put this to storm relative velocity. Now, it looks about the same, I guess. Go back to base velocity. But either way, I would put my tornado about right here. And sure enough, I got debris right about there. Okay. And if we look over here in the top left, there's probably inflow. The reason that notch is there, that's probably air flowing in to the top right part of the tornado from the south and east flowing into it. And that's probably a debris ball that we see a hook, but some pretty high reflectivities that are probably running. Let's see. I'll have to move this to see. If you have GR2 analysts, by the way, I'll move this back up here. And where can I move this guy to? All right, I'll move you down here just for a second. I put my cursor right over this highest red. And if you look at the bottom toolbar, look way down here. See, I'm down at the very bottom. Can y'all see those numbers along the bottom of my screen? Okay. Now I'm going to move my cursor. You notice those numbers are changing. I'm going to put it right over on the top left. I'm going to put it right over the darkest color red I got. And first of all, it's saying that's 53.5 dBz. It tells you latitude, longitude first on the bottom left. And it's saying it's 53.5 dBz. So it's over 50 dBz. So that was rain. That'd be really hard rain, right? It's at 1,594 feet is the center of my beam. It's giving me another lat lon here. I guess the first one wasn't lat lon. The first one was the beam was at 263.8 degrees, looking at 263.8 or like west-southwest, and it's 22.45 nautical miles. I just saw decimals and said lat lon. I apologize. So the beam, let me get my cursor back up there. I had it wrong. Okay, it's saying 263.8, 22.53 nautical miles, 53 dBz, 1,602 feet, and there's your lat lon. And then I'm not sure what it means by 47 meters per pixel. I guess that might be the resolution that we're looking at. Okay, so I automatically in the bottom part of the screen, but you got to leave your cursor over that spot. Wherever your cursor is, that's where it gives you that data. So just like on Radar Scope, I showed you how to use the distance tool and go from right that little blue circle.
Okay.
Go ahead, Paul.
No, somebody just interrupted. Sorry. Please proceed.
Okay. Anyway, so let's go further on, and I may have to move my screen over. And for a while, we ended up losing. They kept the tornado warning, if I remember correctly, but we ended up losing the debris signature. It didn't look as pronounced anymore. See, like right here, there's a lot of blue here, but it's not as pronounced. Okay. And I remember Danielle and I were on, we were worried, well, is it on the ground? We here are in Davidson County, my God, and we still got gate-to-gate winds, even though you see some sort of see that green spike, there's some sort of interference, could be the building, some sort of building, Lord knows what it is, but you're in northwestern part of Davidson County here. And then I'm going to continue to go. And then I want you to notice all of a sudden, right when we were about to cross I-65, it starts to tighten up. The green gets even louder, shall we say. The red isn't showing up as well as it should. Okay, but we're so close to the radar, that may have something to do with it. And sometimes we switch to Hopkins. But notice the red triangle showing up now. And it's got 2.6 at 1,098 feet. If you look at the very bottom, look at the bottom two numbers. The bottom one says 1.6. Remember, they said anything over 1.0 is important. 1.6 only at 770 feet. Uh-oh. Okay. And then 2.6 at only 1,098. And remember, they said anything over 2.5 is extreme. And then it's got 3.4 at 1,900 feet. But either way, those bottom two, it's saying it's extreme. And it's at a little over 1,000 feet. Well, that's bad. Okay. Now, at this point, the correlation coefficient's got so much noise in it, we can't tell what's going on here. Okay. So this, these things aren't perfect. Okay. So here we are, Danielle and I are on the air, and we're looking, is there debris? God, look at this mess, and we're getting so close to the radar, and I've got Hopkinsville's radar saved, but I have to take me a second to pull that in for you. And we might do that, but we were running out of time. Anyway, then we see pretty good gate wins here and pretty good hook. It's still over. It's still showing you this threshold. It's right, but it's got 2.6 now at only 1,098, which it still had before. Okay, so anyway, but it does show the gate wins a lot better. This is right where if you were watching Channel 2, TDOT we got lucky. Our news director, one of our producers, was scanning the TDOT cameras, and sure enough, TDOT camera that was at I-65 and Vietnam Veterans Boulevard, they aimed it off the interstate and started looking. And when it crossed I-65, they were looking south. When it crossed I-65, there wasn't anything on the ground, sure enough. But right after it crossed I-65, getting into the Madison area, suddenly you saw it go down and touch the ground, and that's where it hit that power station. That huge flash occurred, right? So, whoops, let me go here again. Okay, there it is, getting through Madison, almost to Old Hickory at this point, okay? But at this point, and now, if you look in the bottom right, I was going to circle this. That does look like more, well, it's still tough because look at all this blue over here. You got correlation coefficient at the wazoo all over the place. Now look how close we are to the radar, okay? And Danielle and I say, we're so close to the radar, we're getting into the ground clutter. So a lot of this blue that would be, we think, you might think it's debris, it's just ground clutter. But this one right here that I'm circling, it's awfully close to the gate-to-gate winds. You put it right, by the way, you can, on PR2 Analyst, if you right-click, I'm right where the gate-to-gate winds are, I'm going to right-click, and I can hit place marker here, and it puts a little red dot there. And if you look where the little red dot is in this bottom right thing, that red dot's showing up to that blue right there. And it's a mess here because we have ground clutter everywhere. But I bet you if we toggle back, well, yeah, the ground clutter makes a mess. But so this is tough. You don't see it, but it almost, that one right there, because that red dot's, that little bulb's there. At that point, we saw it on camera. And thank God we had a news director and a producer that was scanning the TDOT cameras, because Danielle and I are on these radar things and NWS chat. And when they pulled up the camera, and we're sitting here trying to find the debris signature and correlation coefficient while we're getting into the ground clutter here. Okay. But anyway, look at the hook you got over here. Okay. That's a nice, well-defined hook in about the same place, right? Now here's storm relative velocity, and it's both of them work. So again, this is reflectivity top left. This is base velocity top right, storm relative velocity bottom left, and correlation coefficient bottom right. And our problem that day was it got in the ground clutter. Okay, and I'll try to let it go. And I really probably ought to shut up and let y'all ask some questions, because I think but we still had lots of problems being able to see correlation coefficient. So this isn't the perfect situation, right? But boy, we still had on the top left, look at the hook, so there's so many things you need to look at. You say, okay, this top right, my velocity is a mess here. I'm not seeing everything I used to. It's still giving me one of these. But I look at this top left, I go, wow, so they're still maintaining the tornado warning. At this point, I want to go ahead and let y'all ask some questions, because I've gone on long enough by myself here. And I hope I can answer. And unfortunately, between GR level 3 and GR2 analysts, it makes it difficult for me to do. Let me see if I can pull this back up again and stop share. And okay, so I hope I've answered a lot of questions while I was going there, but I'd like to let y'all ask questions. And I know, Paul, you said you'd have to relate questions, because I probably won't be able to hear from everybody.
Yes, thank you very much. It's very detailed, and I think for some of the junkies in the room, we've been absorbing it greatly. So
that's good.
Definitely some of the challenges you have as a professional meteorologist interpreting live, of course, on TV, but at the same time, for us in the field, we now have, I believe, some great little tricks to understand what we're really looking at, which is most important. A question I have is I notice a lot of your radar angles seem to be very low. Is that the normal settings you leave it at when you're looking for tornadoes or damage signatures? Keep that angle like at 0.5 degrees?
Yeah, we want to know as low as we can, Now, is it important to look at some higher levels? Yeah, but when I'm on TV, most of the time, if we're on TV, and of course, it's different if you're on TV and if you're not on TV, but when we're on TV, the only reason we ever want to look at higher levels is analyzing things, right? On TV, we're trying to show people, here's where the Weather Service says there's a tornado. Here's where it is. Look, that red and the green right there, and we'll circle it with the little thing going around in circles. They'll put a storm track on it and tell you what time it's going to arrive, Now, sometimes hail, I like to look aloft. And I was telling Mark Rose, who's one of the National Weather Service people, and also Sam Schemberger, who many of y'all know those names from the Weather Service, that to me, the hardest thing to do on radar would be a July or August summer thunderstorm. Because a tornado, I'm looking for the gate-to-gate winds, okay? I'm looking to see how low it is, I'm looking to see, they got certain things they want to see how low it is, of course, the farther away from the radar it is, the harder it is for them because they can only see so low, as you know. It's like, but a summer thunderstorm, they watch this core go up, and then they also say, well, we got 50 dBz going all the way up to 40,000 feet. What goes up must come down. That's a lot of weight. And sure enough, that water is going to go boom, come down and do this big downburst, right? And to me, the expertise of them looking at a summer thunderstorm build up and go, we got a lot of dBz aloft, and they're looking at those higher levels, right? And we got a lot of dBz aloft, and that's going to collapse soon. It's not a tornado situation. We don't have shear. It's just July or August, like it is this time of the year. July or August. We're not looking for tornadoes here. We just got summer thunderstorms, and all of a sudden you get all that high, that dBz, or dBz is reflectivity. You get like 30, 40, 50 dBz way up high, that's going to come down. And when it comes down, it's going to be a big burst, a wet, maybe micro burst, but either a wet burst of rain and air that hits the ground and spreads and could do some damage. So I think our Weather Service friends are going to be looking at those higher levels for that. Hail also, you might want to look at higher levels also to see. But I think that and again, with what you guys do, some of y'all are just staying at home to relay what somebody in the field saw, and you're on the ham radio relaying the messages, to MTAERs and all that, okay? And then some of you are actually in your car out there driving around to look for it and relay something. I would say just stick with 0.5 because you're not trying to do a lot of analysts. The Weather Service says there's a tornado warning here. You go, okay, it should be right over here down Highway 96. Okay, and then you get to the point and you see the storm and you confirm to yourself, okay, I'm looking at same spot they're warning and I'm seeing a wall cloud, but I'm not seeing anything reach around. Or, wow, there's a wall cloud. Oh, I'm starting to see debris coming up from the ground. And whatever it is you see, you radio in, and so to me, sticking with 0.5 might be the best. And one thing I did want to mention, for those of you who do go out in the field, obviously, and see, it terrifies me at Channel 2 because we have this storm tracker van, right? And a lot of times we'll have 2 or 3 meteorologists in the building, but they want us on the air tracking. They'll take one of our reporters and say, hey, you go out in the storm tracker van. And I said, well, there's a tornado warning for Dixon County. Go to Dixon. And they're just driving down the highway to Dixon. They don't have a clue. They could get killed. And I tell my news director, he does this. He says, no, I'm not going to send anybody out in the van until it's gone by. And if there's damage, we'll send them out there. But when I go out there, number one, you do know that, you've got the icon down here where you see, and I don't care how much you pay for this, you got your location right here. You click on that, and it's going to show you where I live, by the way. That blue dot right there is where I am right now. By the way, yes, I have a pontoon boat sitting on Old Hickory Lake right outside my window, and it's and I'll put the cities back on just for the fun of it, but I got this all backwards, so I can't see anything. But anyway, so that icon is where I'm at. And if I'm driving around, that little blue circle moves, okay? And so I can see where I am in relation to the storm, okay? So when I'm in that weather van And if you're out and you're doing the spotting, it's so important that you look at that at your location using your GPS tool on your storm on your radar scope, and you see where you are in relation to that red and green couplet, okay, or the storm, whatever it is, okay. Most storms are moving from west to east, southwest to northeast, northwest to southeast, west to east, whatever. Approach from the south. If you're to the north of the storm, well, don't try to just go punch through that storm. You're just going to get number one, you're liable to punch through the storm, have hail damage your car, and then next thing you know, if there is a tornado, there it is, and you're in the middle of it. If you're coming from the south, most of the time the tornado's on the south side of it. Okay, those tornadoes going from west to east. You know, you have that classic hook on the southwest side, and you coming from the south, you'll be able to see it without being in it. Okay, and so I always want to tell you, try to approach from the south. I know I have gone down to Lawrence County one time back during COVID, as a matter of fact, and we had a tornado warning, and I went all the way past the tornado's path, turned around on Highway 43 and came back from the south, parked myself in just north of Lawrenceburg, and looked at my GPS where I was in relation to the storm. Could see that it was going to pass probably a half to a quarter mile to a half mile to my north. So I knew I was safe. You know, I could say, okay, I'm definitely, it's not coming to hit me. It's going to go to my north. And I sat there and watched it go by. And I was able to relay to Channel 2 while Danielle was on the air that I'm watching it go by and I'm not seeing anything reach the ground. I'm seeing where the tornado would be if there was one, but it's not reaching the ground. And they were in the middle of tornado warning. That was good and important information. But had I come from the north and just punched through it, I'd have been in the middle of all that rain, maybe some hail. And if there was a tornado, I might have just punched right on into it. So, Paul, go ahead and give me another question here.
Okay, let me throw it to the room here, and we'll take questions. Are there any questions online first? I'll ask Ronnie. Okay, no questions there. We have a question in the room. Go ahead, sir, please. Did you have a question or no question? Oh, no, just a raised hand. Well, I think since we've run over, you've had some great detail, Davis. So right now, I think you've nailed a lot of the questions we submitted in advance, and we really appreciate it. This was fantastic detail, and I know for those of us, and most everybody in the room has radar on their phone, as well as a bunch of us have the GR levels. This has been very, very helpful. So thank you kindly for sharing your time with us this morning on your Saturday. I know you got to go into work here in a few hours, and hopefully it's a quiet day for you. But on behalf of the Williamson County ARES group, we thank you very much for sharing your insight and time and helping us understand radar much better.
Well, thank you very much for having me. I love talking about it, obviously. And, some of my colleagues at the National Weather Service, which is right down the road from me, that's why I'm pointing that way. You might get somebody like Sam Schamberger or even Christy Hurley to come meet with you one time and talk about these things because, they're like, they've forgotten more than I know. Okay. And there's like little details, like I was telling you, like these scans, this scan might be 30 seconds sooner than that scan. And that's why this doesn't line up with that thing. They had to go to school and learn every little detail of that, whereas I know more of the generalities. But anyway, I need to let you guys go get on with your day. And I appreciate y'all having me.
Thank you very much. And we really appreciate it, Davis. Very enlightening. Thank you for your time.
You're quite welcome.
Have a great day.
You too. Bye-bye.